Now we are solving plane stress problem for the pressure vessel, thin pressure vessel. For that purpose, obviously preference is structural. Okay, preprocessor, under that element type we will add a cell solid element 400 182 quad. Go to the options, make the element behavior as a plane stress with thickness as on. Okay, close that element. Real constant, we are doing the axisymmetric problem. You observe here for the pressure vessel. So we are plotting the area and we will plot the result for the 360-degree by considering the one single strip. So we will not give as input as a real constant. Okay, we will not give as the input as a real constant. Directly we go to the material property, material model, structural linear elastic isotropic 2E5 and 0.3 as a Poisson's ratio. Okay, material model is defined. Now modeling, create area by two corners. Okay, now radius is 50, so x will 50, y will 0, width is suppose 20 and height is suppose 300. Height is 300. Okay, so it will uh, plot this strip, this area. Okay, how? Once you click on OK, right now this is the thickness you get strip. Okay, because pressure vessel and which is subject to internal pressure, so it is axisymmetric problem. It is axisymmetric problem. So about y-axis it is symmetric, right? So we are only taking a cross section area at one section at cross section area. Okay, we only taking a cross section area and we will apply the pressure and we will evaluate the result for the overall pressure vessel using axisymmetry. Okay, then go to the mesh tool, set area, apply. I will assume 5 as a element edge length 5 mm. Okay, go to the mesh tool again, map meshing, mesh, select the area. Okay, right, you can observe 20 width is there. So 4 element is being created and 300 mm is our height. Okay, meshing is done. Now we apply the load, define the load, apply structural displacement on lines. So we'll select the top and bottom and top edge because here the ends are welded. So at the weld location, we are consider the constraint. We are consider the these are the constraint. Apply. All degree of freedoms are 0. Okay, so you can observe here the constraint are being applied. Now we apply the pressure on line again. Select that inside line, apply, and we will apply the suppose 1000 of Pascal. Okay, so pressure is being towards the area, internal pressure. So direction is correct. You apply with a positive magnitude. Okay, then solution, solve current LS. Sorry, this is showing that real constant set is undefined. Okay, so we will go to the preprocessor element type. We will opt the behavior plane stress with thickness. We use as axisymmetric. We use here as a axisymmetric. Okay, make that change. Element behavior is a axisymmetric. Okay, where instead of plane stress and plane strain, under the element behavior you have to use the axisymmetric problem. Okay, I forgot to define that. Now go to the again solution, solve current LS. Now solution is done. Okay, now you can observe a result, general postposition, nodal solution. First we plot the DOF solution, displacement vector sir. or x component of displacement. Okay, this is the x component of displacement. You can also get a y component of displacement. Okay, we'll observe the stress value, stress x component, apply. Okay, so you can get the maximum value of stress is 666 megapascal. Y component, apply, right? It is 3387. What is the z value in a plane stress problem? What is the z value? Anyone? What will be the z value of stress? We are solving the plane stress problem. So what will be the probable value before plotting the contour plot, or before getting the contour plot? Can anyone guess what is the z component? Yes, anyone? What is the stress value for the plane stress problem along the z direction? समजते मी काय बोलतोय? Yes, 0. Right, Bhakti and Vishwajit and Pranam. Okay, so we will check it is 0 or not. Apply. Okay. Z component, right? Due to axisymmetric in nature and out the diameter to the thickness ratio, which will come, probably that will be 0, but due to that nature, we will again check with the element type. Before that, I will show how to look at the style, axisymmetric expansion, cyclic expansion, plot control, right method, style, axisymmetric expansion, 2D axisymmetric problem, 3/4 of expansion, apply. Okay, you go to isometric. You're going to observe this by using the single strip. You can evaluate the result. You can evaluate the result for the overall pressure vessel. Okay. Preprocessor will change the element type behavior without axisymmetric. We will consider as a general plane stress problem. Solution. XY. Now shear stress you can observe because what is happening, this is geometric circular, right? Actually it will be showing in 0, but the geometry whatever we have drawn, right, the z direction it is may be considering the different one, location orientation may be different one. Okay, but you can observe the shear stress value, that is a shear stress xy is all present, tau xy is a present. Okay, you can get some value here, but you observe the shear stress value along yz it is showing the 0, right, as well as along the xz it is also showing the 0 value. Okay, so stress in that region will be 0, stress in that plane will be 0, shear stress, right? We getting the displacement because of the nature, actually it is must be zero theoretically, but we are not getting that z component. But shear stress can observe, the shear stress can observe yz and xz component, that all zero, that you don't get any value here, you don't get any value here. Okay, so this is the way you can evaluate the result for the uh, pressure vessel. Okay, you can observe we are only draw the area or single strip of cross section, but you can evaluate the result for the full pressure vessel. So whenever there is axisymmetric problem, you can use that axisymmetry. You can use that axisymmetry to plot the or to get the result for the overall cross section. Now this is symmetric about y-axis. This is a symmetric about the y-axis. Geometry is a symmetric about the y-axis. Okay. Okay. Plane stress. Again we solve. Now we again go to the result, central cross using nodal solution. We will plot the result of trace along the Z. Apply. Okay. Now you can observe. Forgot, I have taken wrong. So you can make the changes to the option. Instead of first option, you have to select plane stress. Okay. The type of his problem is a plane stress. So you can click on plane stress. Okay. Close. You can go to the solution. You can solve, and you can general purpose view the result. Nodal solution. Right. Now you can observe. X component is there. Right. X component is there for the pressure vessel. Y component of stress is also there. That is normal stress along the Y direction, but normal stress in Z direction will be zero. Similarly, you can observe the shear stress in XY plane. There will be present, right? So you get some 25,000 certain value, but in YZ you can get the zero value, and XZ is also you get zero value. Okay. So this is the plane stress problem. Element behavior मध्ये काय अजून करायचं? By default, it is a plane stress problem. Okay. So you can use of axisymmetry. You can use that axisymmetric problem right. You can use that axisymmetric problem to tackle such type of problems. Plane stress problem. Okay. Plane stress problem. Use of axisymmetry. Okay. So you can observe that after applying the pressure, the ends are constrained. So pressure vessel is being subjected to a deformation, and 160 deformation is very large value for whatever the cross section we have considered. Whatever the cross section we have considered. So it may get fail. It may get fail. As you observe the stress value, X component of stress. Sorry, I have to stop that animation. You can observe the nodal solution, X component of trace. Okay, this is 34,780. So it is exceeding the yield or ultimate value. So it may cause the failure of pressure vessel. It may cause the failure of pressure vessel near the weld joint, or in case of Y direction you observe, it may get fail again at the weld location. Okay. So this is the way you can use symmetry or axisymmetric problem, right? 2D axisymmetric problem. So this is applicable to not only pressure vessel, flange असेल, gear असेल तुमचा, flywheel असेल, right? So you can model that and you can solve. So make sure that you have in the element type you have correctly defined element type option, that is a plane stress. Okay.